That is huge display will be there now. Nowadays, those are replaced with smart TVs, LED, isn't it? But earlier period we had even now also we have CRT based displays, isn't it? So that cable size, if you compare with the present cable size, the size varies. You wonder why? And also if we have some other type of transmission line or lines also, we cannot say that is transmission, but that is also used for transmission of waves, that is called wave guides. Isn't it? So we are seeing the transmission line is present at many places. Okay, we cannot say any place is left without a transmission line. Okay, so as an EC engineer, it is essential to know the transmission line and how it behaves, what factors it controls. Okay, those things we need to know. So that you will be learning in this subject. What is my next question? Are there any differences between network theory and transmission line theory? See, in this semester, you are studying all the basic subjects, isn't it? So you are studying about signals and systems, network theory, electromagnetic fields, digital circuits, isn't it? So in that network theory, I think today sir has started the class. So how will you approach the subject? Can you tell a few points from his introduction? You've gone through my mail, no? So can you tell me any difference between network theory and transmission line theory? There will be some differences, isn't it?
In theory, we will see about many complicated circuits and things, and in transmission lines, we will see about how power is transferred from power generating unit to our house. Like.
Oh, okay. See, network theory is not always complex circuits. So complex we can say that is having a reactance, real and reactance, resistance and reactance. That way we can say complex. As a complex word, we cannot attribute to the network theory. Okay, complex we can take that as the resistance plus reactance. Okay, so that way you are telling the difference. You will be dealing about complex components. Okay, resistance, capacitance, and for transmission line, we are not going to study about power generation to the load. Okay, we are concentrating about the signal. Okay, so signal and the source side and the load side. Okay, how the signal is getting into the transmission line, and from the transmission line how it is going to the load. Okay, what are the things we need to consider for properly transmitting the signal? Those things we will be seeing. Okay, but there is a main difference between network theory approach and transmission line theory approach. Have you browsed any details regarding this? Can I get some other answer? Okay. In your 12th standard subject, you have studied about resistance, capacitance, inductance, isn't it?
Yes, ma'am.
Yes. Those were physically locatable, isn't it? Those components we will be seeing and we will be knowing the values. So that is what the network theory is dealing about. So when you come to campus, you will be you will be doing some experiments in network lab also and circuits lab also. There you will be seeing the components, lumped components. We call those as lumped components. We will be touching, we will be seeing. Okay, we will be connecting. Okay, resistor, capacitor, inductor, isn't it? But in transmission line theory, what we are using, what we are discussing about, in circuit theory, we will be discussing about the resistor, capacitor, isn't it? Resistance and reactance, complex circuit parameters. Here, what will we be discussing? How the component, what is our discussion point here?
Wires and steps.
Yes. Wires, and that is transmission lines. Okay. So that transmission line is also having the RLCG values. You know that? That is what you are going to see in the unit 1. See, the transmission line can also be equivalently drawn as circuit, RLCG component. See, but we are not able to see where R is present or where L is present. But it is present. Where it is present? Can we locate? In circuit theory, we are locating and we are calling those are as lumped components in circuit theory. But in transmission line theory, whether the length of the transmission line is 1 meter or 1 centimeter, the components are present. So these are present in a distributed nature. Every unit length of a transmission line, we need to consider the presence of RLCG components, and these are all present in distributed nature. Okay. When we have to give importance to the distributed components in network theory, you will be doing some circuits. You will be connecting the R, L, C, G, all the components using wires. Okay. That time, will you consider the distributed parameters, presence of distributed parameters? You will not be there. You will not be bothered about the distributed parameters presence in the wires. But at one point, okay, we need to consider the distributed parameters. Okay. Can you guess what parameter is that? What are we going to say?
Electricity.
Signals.
Signals. Okay. So signal is having some characteristics, isn't it? What are the
Yes,
characteristics signal has? What are the characteristics? Signal? Yes.
Frequency, amplitude.
Very good. Frequency, amplitude, phase. Okay, these are the characteristics of the signal. So, if the frequency of the signal is increasing, what wavelength will be?
Decreasing.
Decreasing. Okay. So, C by lambda is F. Okay. Once F increasing, lambda decreasing, that is the relation. Okay. So, in circuit, when we consider the circuits for some low frequency regions, we will not bother about the presence of distributed components in the circuit. But when we go for high frequencies, okay, when we take the signal propagation, that time we will be considering the frequency and corresponding lambda value. Okay, so the lambda is the wavelength. In circuit theory, consider you are designing some circuit for 1 kilohertz. Okay, so 1 kilohertz, what is the wavelength? Three into 10 power 8 divided by 10 power 3, isn't it? So 3 into 10 power 5 meter, isn't it? That is the wavelength. So 3 into 10 power 5 means 300 kilometer. So what will be the circuit length? See, you are connecting some RLC components in circuit lab using some wires. Okay. So the wires, what will be the length of those wires? You will be working on only with breadboard, no? The size of the breadboard will itself maybe 20 centimeter or 30 centimeter. And the wire will be some 5 centimeter or 10 centimeter. Can we compare these lengths? 300 kilometer with 10 centimeter, is it comparable?
No, ma'am.
No, ma'am.
No. So that time we will not consider. We will not consider about the parameters of a wire. But if frequency increases, for example, you are designing for some 3 gigahertz. Okay. So 3 gigahertz, what is the wavelength? 3 into 10 power 8 divided by 3 into 10 power 9. Okay. 0.1. So 0.1 meter. So when it is 0.1 meter, the length of the line and the wavelength is comparable. That time we need to give importance to the distributed parameters present in the line. Okay. So this is the main difference between circuit theory and transmission line theory. In circuit theory, we will be discussing about lumped components. We will be able to see the components physically. We will be able to locate. But in transmission line theory, okay, the line is having distributed parameters, and that will be measured using some kind of experiments, and those values are given in the manufacturer data sheet. Okay, we will be knowing what is the RLCG value for per unit length of a transmission line. Okay, those things we need to consider when frequency is comparable to the wavelength. Is it clear to you?
Yes, ma'am.
Yes, ma'am.
And about waveguides, can anybody else add some points in addition to Sanjay? So when we are discussing about wires, transmission lines, we call it a signal. Okay. At high frequencies, the signal is transmitted in the form of wave as field, isn't it? So if frequency increases, lambda decreases, then the comparatively the dimension decreases, isn't it? So that time we are going for waveguide. Okay, some kind of structures for high frequencies. Those are called waveguides. See, in our TV example itself, in olden days, the cable was huge size, isn't it? Now the dish TV connected to our home, receiver. This dish receiver. Now we are seeing only small. Mic shaped one, smaller size. Can you guess the answer from these discussions? Why the size of the transmission line is reduced? That is, I don't mean the length, I mean the diameter. Why diameter reduced? If you compare with the old cable TV with the present dish TV, or present set-top box TVs, why the diameter of the conductor is reduced?
I think before waveguides are included in the transmission lines, and now there is some new technologies.
Okay. Actually, earlier days we were using lower frequencies. In megahertz only we used, isn't it? But now we are using in gigahertz. As frequency increases, dimension decreases. That is the reason. Okay, Sanjay? Earlier, in megahertz region we were using. Now we are using in gigahertz region. So, comparatively, the size of the transmission line diameter also decreases. And waveguide, some kind of waveguide component you can see in your dish. So in your dish, so this dish is a parabolic antenna. Okay. So from there we will be receiving the signal. Okay. So that all the received signal will be collected at one point and that is given to the TV via a transmission line. So you go and see there. Some kind of low noise amplifier will be present. That we call it as low noise block. Okay. So those things, if you find time and if you have some kind of intuitiveness, if you also have opportunity, you just see how the dish is connected to your home TV. So these questions we have seen. Then up to this, any doubt?
Ma'am,
Yes.
ma'am, you told that if we increase the frequency, we are decreasing the diameter of the wire.
Actually, we need to find the suitable transmission line as per our frequency, isn't it? We are using some transmission line for telephone. When we come to TV connection, we are using other. And when we go for a little higher frequency, we go for waveguide, isn't it? So according to the frequency of signal transmission, the transmission line dimension varies. Is it okay?
Yes, ma'am.
Dhanvantraj. Why only 48 people are connected? What about the remaining people? See, yes, inform them to connect regularly.
Ma'am, generally we only get this amount, ma'am. This strength.
Okay. But attendance will be marked. Okay. If you must have some minimum 75% attendance. What lambda by rule, ma'am? Okay. That we will discuss in the unit 2. Okay. Lambda by 4 is having so much advantages. We are moving point of view is increasing. Okay, so when the signal frequency, when the wavelength of the signal is comparable to the dimension of a transmission line, it is having that distributed components are having some effect on the signal. Okay, so similarly, each length of transmission line, lambda by 2 length, lambda by 4 length, lambda by 8 length, every length will have some significance that we will be exploring in unit 2. Siddharth, is it okay?
Okay, ma'am.
Any other doubt? And your textbook you cannot download. If you want, you can buy. Just a second. Yeah. So this is your syllabus. Hope the screen is visible.
Yes, ma'am.
Transmission lines and waveguides. So in unit 1, we will be knowing about the transmission line equations, voltage and current waves. And I already told you some distributed components are present, RLCG, and that corresponds to some secondary components called characteristic impedance and propagation constant. And also we will be concentrating about how the signal should be connected to the transmission line. Okay, if it is not properly connected, okay, if the source is not properly connected to the transmission line, there will be some mismatch effect. Related to that, we will be studying about SWR, reflection coefficients, and solutions for different terminations, transmission line loading. Okay, everything we will see in depth in the next class. In unit 2, we will be studying about impedance transformation and matching, quarter wave, half wave transformers. See, just now one person asked, what about lambda by 4 length? Those things we will be knowing in unit 2. And also about binomial Chebyshev transformers. And there are different types of matching. Okay. See, consider the case of a water conduit, water pipe itself. See here, if the water is freely let flow in the ocean or canal, it will be going. Okay. So if that is coming via the, okay, that way also we can distribute. Okay. This here, no unintended users cannot tap the water. No, if it is coming in the pipe, the same thing applicable for transmission lines also. See, here there are, I have just related the transmission line to the water flow in the pipe. See, if it is let to open, it will be continuously going. If it is properly closed or properly, this pipe is properly fit, then the flow of water will be going smoothly. Okay. The same thing is applicable for transmission line also. The impedances of a transmission line and the source load must be matched. Then only the flow of signal will be smooth and we get maximum efficiency out of the transmission lines. Okay. See, in case if here you see, this is only just a water pipe. See, there are some mismatches. If these are not properly connected, what is happening? Some kind of wastage. Okay, water is getting wasted. Similarly, in our transmission line, if there is a mismatch, okay, if there is a mismatch, then we will not get good efficiency. Okay, our efficiency of our system will decrease. See, here this is physically, we are here it is a pipe and here also it is a pipe, and these for getting matching and proper without leaking, it must be made proper, no? Similarly, in our transmission line, these kind of things we will be quantifying in terms of characteristic impedance. Every transmission line will be having some characteristic impedance value that must be properly matched. Okay, if we are not able to match, there are some techniques. Okay, those techniques we will be seeing in unit 2. Those techniques. What is the significance of different length of a transmission line, and what is the use of binomial Chebyshev transformer? In addition to that, what are the different types of matching available? Single stub matching, double stub matching, triple stub matching. Okay, these things we will be studying in unit 2. And in third unit is for graphical tool. So whatever calculations high cost equipment can do, the same thing we can do using one flexible chart. That is called switch chart. Okay. Now itself I will need to buy some switch charts, some 26 charts, and I will pay you. Okay, when we go to unit 3, when I start unit 2, that time itself I will be starting solving the problems and see. Switch chart, these units will go parallelly. Okay. So the bicycle charger shop and EC2. And this unit is about solving the problems. Okay, whatever the problem we are living in, unit 1 and 2, how those can be solved easily using Smith chart that we will be doing in unit 3. Then unit 4 is about waveguides and transmitters. There are different types of waveguides and how the AC is propagated in waveguide. What are the different modes of propagation? Okay. And then what are the processing data? These things we will be studying in unit 4. And in unit 5, we will be seeing some sort of planar transmissions. What are planar transmissions? I will show you some example. See here. Is this slide visible to you? Are you seeing?
Yes.
Here you are seeing PCB. Okay. But this is also PCB and here you have some kind of lines and there is some more thicker, some more thinner. And here you see this line is having some shape, isn't it? It is connecting these two and also these two. But this is bigger than what we normally see on PCB, isn't it?
Yes.
Have you? Yes. In PCB, we will be having the copper lines for connecting 2 points. But here you see, this is also connecting, but it is having some design. Okay. It is different from what is seen in the PCB. Okay. So these are all called planar transmission lines. See, plane, you know, plane, this is a surface. It is also like a plane, okay, it can be made on a plane. So these are all called planar transmission line. It is making one component here, okay, it is making a power divider, okay, or directional coupler. So that component is made just only using a transmission line on a, I can say it is a PCB. On a PCB, some structure is drawn. Okay, it is not drawn roughly. Based on calculations only, it is drawn. It is designed. Okay, but this is called planar. Okay, these things as an AC engineer, we need to know these things also. No, that's why you are studying about this subject. Okay, this is about Unit 5. In Unit 5, we will be studying about planar transmission lines, microstrip line. In that, there are many types: microstrip line, strip line, slot line, coplanar waveguide, fin line, and microstrip MIC as design aspects, computer-aided analysis and synthesis. See, in our college we have HFSS software and we have MATLAB. Okay, when you come to campus, you can use those. And in the HFSS, you can also design the transmission lines. You can analyze the properties. If you have interest in designing those and analyzing, you WhatsApp me. I will tell you how to do that. Okay. And at the end, you will be able to know these things. So whatever we are studying in this unit wise, that you will be able to analyze. Regarding the subject, there are two textbooks for this subject. One is Microwave Engineering by David M. Pozar. Okay, Microwave Engineering by David M. Pozar. This book you can download. Okay, it is downloadable. It is available online. And the second book is about networks, lines, fields by J.D. Ryder. Okay, J.D. Ryder. This book you may not be able to download, but if you are interested, you can buy. Yeah, mainly this book, the networks, lines, and fields will be covering 3 units. Okay, first 3 units. And the Pozar book will cover all the 5 units. I will be using both the books. In addition, we have references, Foundations for Microwave Engineering by R.E. Collin, Electromagnetic Waves and Radiating System by Jordan and Baldwin. Okay, these are the books. If any questions are there, you can ask. Okay. Can you introduce for a minute, every one of you? Can you tell your name, hobbies, aim? Where is roll number 1? Can start.
Yes, ma'am.
Yeah.
My
start.
name is A. My name is A. Durga Prasad. I am from Andhra Pradesh, and my hobbies is playing cricket,
Okay.
watching movies. Thank
Aim?
Thank you.
Okay. Aim also you can share.
Said ma'am. Durga Prasad.
Okay. Aim.
A.
Hmm.
To get any
To get placed.
in any software company to get job.
Next, number 2. One way proceed.
I'm Hashni from Andhra Pradesh, ma'am. And my hobbies are watching TV and reading books, ma'am.
Okay. Aim also you can share.
And my aim is to get placed in top companies, ma'am.
Okay. Next. Good.
Hello, ma'am. I'm Chandru from Karaikal.
Yes.
My hobbies are playing games, and my aim is being settled for lifetime.
Pardon?
Lifetime settlement.
Okay. Next. Fine. Fine is
Deepa from Tamil Nadu.
okay.
My hobbies are video editing.
Okay.
To get a good job, man.
Okay. Next. Good. Hmm.
Pondicherry.
Yes.
My hobbies are to play football and learn new things. And my aim is to learn these EC subjects very well and to become a good engineer.
Good. Next.
Ma'am, my name is Deepan Kumar. I'm from Karaikal. My hobbies are playing cricket, football, watching web series, like that. And my aim is to place at good company. That's it.
Okay. Next. Many cricketers in your class. Pavitra. Number 8. Number 9. 8 is not turned up, no?
No, ma'am.
Yeah. 9.
9 is absent, ma'am.
Okay. 10.
Good afternoon, ma'am. I'm Harishankari from Karikal. My hobbies are playing badminton, and my aim to get a good job in top-notch companies.
Okay. Good. 11.
Good afternoon, ma'am. I am Hari Krishnan from Pondicherry. My hobbies are watching TV, play music in keyboard, and reading books. My aim is to become a good businessman in an engineering field and excellent in my department subject.
Good. Next. Yes, next. 12?
Ma'am,
There's
12
no
isn't
12.
there, 13.
Okay, 13. 13? 14?
Ma'am, my name is Jubin Thomas Kuriakos. I am from Kerala, and my aim is to build sources of income and then live as a farmer.
Okay. Good. Next.
Good afternoon, ma'am. I'm Kalidas Denny. I'm from Kerala. My hobbies are watching movies and listening to songs. My aim is to become a good engineer. First, thank you, ma'am.
Good. 16? 16 not there. 17? 18?
Ma'am, 16, ma'am.
Yeah, Ajay.
Ma'am, my roll number is Ajay Kumar. And my hobbies are listening music and drawing, ma'am. And my now aim is to become a best engineer, ma'am. And my final aim is to become a richest person, ma'am.
Okay, good. 17 is there.
No, ma'am.
18?
Good afternoon, ma'am. I'm Sunil Kumar from Andhra Pradesh. My hobbies are playing cricket and watching movies. And my aim is to become a good engineer, ma'am. Thank you,
Good.
ma'am.
19? 19? It is only roll number wise. No, next person can continue. 20?
Ma'am, I am Likita from Andhra Pradesh. My hobbies are watching movies and drawing. My aim is to become a good engineer.
Good. And our college have announced for one drawing competition. You people may be aware of that, no? For the Independence Day celebrations, they have announced for drawing competition.
Yes, ma'am. We
Okay.
were informed about singing.
But
And
drawing competition notice also there in our website. Okay, you check our website. Otherwise, I will WhatsApp you. Next, 21, 22, 23.
Ma'am, I'm Ashwant from Andhra Pradesh, ma'am.
Yes.
My hobbies are cricket, playing cricket and volleyball, ma'am.
Okay. Aim.
To enjoy life, ma'am.
Good. Next, 24.
24. I am Masudan from Andhra Pradesh. My hobbies are watching movies. I don't have a particular aim.
You will be having.
But it changes from childhood.
Yeah, it changes, but the objective for short term and long term will vary, isn't it? 25.
Hello, ma'am. Madhusudanan here from Pondicherry.
Yes.
So my hobbies is like to watch some video content, read books, play football. That's all. Aim is to research on something, create new things.
Good. See, in our college, we are also part of our students also doing course in Coursera. Okay. In that we.
Great.
So Coursera you can do, and also NPTEL you can do, as well as IARS is having some e-learning portal. For that, I am the in charge. If you register in that login, I will approve that. IARS, e-learning.iars. If you browse, you will get the information. Next person, 26.
Hello, ma'am. I'm Mahesh from Karakal. My hobbies are playing cricket and football, and my aim